Question 5. Explain the role of myelin in the conduction nerve impulses in myelinated neurons. So we've got our neuron there, and there's our myelin sheath made of Schwann cells, and the purpose is to electrically insulate this axon, and so then only the depolarizations occur at the nodes. The impulse jumps from node to node, and so that gets quicker. So overall it makes the nerve impulse faster, and we only need 2 marks here. Makes nerve impulse faster. And then 1 mark for many of the reasons that we said previously how it does that. So it provides electrical insulation. The action potentials are only generated at the nodes. So action potential or depolarization only at the nodes, and so this is saltatory conduction. There is another couple of marks that you could have had. It prevents the loss of ions. And so it's much more efficient, or helps maintain the electrochemical gradient, but it's 2 marks, so I'd say one of the more obvious things. 5b, the graph shows an action potential. Give a change between point A and B. So A is here, B is up there. What's the change? What's that? So it's going from minus 70 to plus 30. So it's going, so there's our 0. So that's 70. From minus 70 to 0, that's 70, plus another 30. So that's going to be 100. So this question is getting the idea over that it's a big jump, is this. And then part C is just giving us some explanation what's going on in terms of sodium and potassium ions between A, B and C. So this is just you telling us what's going on, and there's just give us a full story of how a nerve impulse travels along. So they'll give you up to 6 marks, and it depends on the full answer really. There's not any kind of specific marks. So A is our resting potential, and then sort of between A to B, that's our action potential or depolarization. Or we could say this is polarized to try and help you there. And then sort of B to C, that is our repolarization. So we've got our, let's just get another copy of this graph. So here's our graph again. So we could give at A we've got, A we're going to have our minus 70, B we're going to say plus 30 millivolts, and then C, that's back at our, to B and C we've had our repolarization. We could talk about hyperpolarization and back to resting potential at minus 70. We could mention minus 90 down there. So we're going to say sodium channels open, sodium moves in by diffusion, and then we're going to have sodium channels close, potassium channels open, potassium moves out, hyperpolarization as more potassium moves out, but then we get our pump going to restore resting potential. So those are the key points, and we just need to get over that main story. So minus 70. A depolarization is to plus 30 millivolts, and then repolarization is to minus 90 millivolts, then to minus 70 millivolts. Resting potential, we've got our sodium potassium pump, which is 3Na plus out, 2K plus in, and that creates our gradients. So creates gradients for sodium, more out, and potassium, there's more in. So the inside is more negative than outside, and that's why we can say it's minus 70 millivolts, or we can say it's polarized. Then in our depolarization, the most obvious thing to say is that sodium channels open. Sodium rushes in or diffuses, and we could talk about our thresholds here. We could say minus 70 to minus 55 millivolts, that's our threshold. And then if so, then it will go to plus 30 millivolts if we reach the threshold. And that's our all or nothing law. And then, at the end of this process, then our sodium channels are going to close at 30 millivolts. And then we're back into repolarization. So I'm going to say our potassium channels open, potassium moves out by diffusion. And so we've got potassium moving out, and then this is our repolarization. We could say you might get hyperpolarization to minus 90 millivolts. And this is sometimes termed our refractory period, where we can't get another action potential. So harder to get another action potential, because it'd be harder to get to this minus 55 from minus 90. It's too much of a jump. And then resting potential re-established by our sodium potassium pump, and then we're back to the start of the story then. So you don't need absolutely everything there for all of the 6 marks available, but quite a few people were getting the sodium and the potassium mixed up, and sometimes the names of the stages and polarized and depolarized. Watch the video again that we showed you.